The solar system, our neighborhood in terms of the cosmic world. Home to planets, moons, comets, asteroids, and more, the solar system is full of fascinating worlds and wonders, and today, I want to take you on a trip through the places and objects that make up the solar system. Before we start, make sure to subscribe for new astronomy and astrophysics videos coming soon. So just a quick side note before we start, any information that I found and cited will appear as a number like this on the screen. The number will correspond with a number in the description down below, which will lead to a citation and a link where the information was found. So our first stop on the tour is going to be the sun, the center of the solar system, the thing that makes us go round. The name solar system literally means sun system, solar meaning sun. The sun was the first thing to form in the solar system some 4 billion years ago from a large cloud of cosmic dust and gas. Over time, this dust and gas collapsed on itself due to gravity, and boom, the sun was born. The sun itself is a main sequence yellow dwarf star that can reach temperatures of up to 2 million degrees Celsius. The sun creates this heat as well as its light through a cycle known as nuclear fusion. In the sun, this is done through the process of fusing hydrogen atoms together to create helium atoms. During these reactions, energy is released in the form of heat and light. The sun itself is big, like crazy big, so big that you would need a little over 100 Earths side by side to fit across the disk of the sun. Even sunspots, which are smaller areas of the sun that are slightly cooler than the rest of the surface, can grow to be the size of a few Earths across. Despite the fact that the sun is what provides us with life here on Earth, billions of years from today, the sun will run out of hydrogen to fuse. As it does, it will expand and grow into a red giant star, growing into the orbits of Mercury, Venus, and possibly Earth. Once the sun runs out of hydrogen, it will expel its outer layers into space, creating a planetary nebula, leaving behind a small white dwarf star. So next on our trip, we have the first planet from the sun and the first of the 4 inner planets, Mercury. Mercury is the smallest planet in the solar system, with some moons in the solar system being bigger than the planet itself. Mercury orbits very close to the sun, completing a trip in just 88 days. This is why it's difficult to see Mercury in the evening and morning skies. When it is visible, it's often not too high above the horizon due to how close it is to the sun, and it can often get lost in the glare of the evening and morning skies. Mercury doesn't have an atmosphere. This means that the side of the planet that faces the sun can reach temperatures well above a few hundred degrees Celsius, while the side of the planet that faces away from the sun can reach temperatures well below a few hundred degrees Celsius. The surface of Mercury is full of craters due to meteors that have impacted the planet. And another fact is that Mercury doesn't have a moon. The reason being that if it did have one, it would instantly be pulled out of Mercury's orbit due to how close the planet is to the sun. Fun fact, Mercury is the only planet in the solar system that hasn't been viewed through the Hubble Space Telescope. The reason being, Mercury again is too close to the sun. If Hubble turned to view the planet, its optics and computer systems would be damaged. Next up, we have Venus, the second planet from the sun. A fact that might surprise some is that Venus is the hottest planet in the solar system. Now you might be thinking, well, Mercury is the closest planet to the sun, so wouldn't that make it the hottest? The difference here is that Venus has a very thick atmosphere, a greenhouse effect that's gone terribly wrong. Because Venus's atmosphere is so thick, it traps most of the heat that enters the planet's atmosphere. Temperatures on the planet can reach over 400 degrees Celsius. It's this thick atmosphere that makes it the brightest planet in the night sky, and the third brightest celestial object behind the sun and the moon. Talking about extremes, Venus has the longest days in the solar system. While here on Earth it takes 24 hours to complete one rotation, On Venus, it takes up to 243 days to complete one rotation. It actually takes the planet longer to do a trip around the sun than it does to make one rotation on its axis. Next on our list, the third planet from the sun, our home, Earth. Earth is so far the only place in the solar system that is able to sustain life as we know it. The reason that Earth is able to support such advanced life forms is due to its position from the sun. Earth is in what we call the Goldilocks zone. The reason we call it this is that the temperatures here on Earth are not too hot and not too cold, and water is able to stay in a liquid state because temperatures on the planet are just right. Earth also has one moon, which we call, well, the moon. The moon formed during the early stages of the solar system after another large planetary body hit the young Earth, shooting rock and material out into space. Over time, the rock and material came together to form the moon. The next object on our list is Mars, the fourth planet from the Sun and the last of the inner planets. Mars is smaller than Venus and Earth, but bigger than Mercury. Mars is named after the Roman god of war, and the reason it's given this name is that, to the naked eye, Mars appears a reddish-orange color in the night sky. The ancient Romans associated this red color with blood, and thus Mars got its name after the Roman god of war. The reason Mars appears this reddish color is due to a chemical compound called iron oxide, or as you might know it here on Earth, rust. The rocks that make up the surface of Mars are mostly made up of iron, and when the iron in these rocks are exposed to oxygen present in Mars's atmosphere, they oxidize, giving them a red color. Mars is home to some extremes of its own as well. Mars has the largest volcano in the solar system, Olympus Mons, which stands at 25 kilometers high. To put that into perspective, the Burj Khalifa, the tallest building on Earth, is around 820 meters tall. You would need to stack over 30 Burj Khalifas on top of each other to reach the top of this volcano. Mars also has two moons, Phobos and Deimos, both relatively small in size, about a dozen or so kilometers across. Now, the interesting thing about one of the moons, Phobos, is that it's in something called orbit decay. This means that as time goes on, the moon is slowly being pulled closer and closer to the planet Mars. It's predicted that in about 100 million years, Phobos is going to get close enough to Mars due to its decay that Mars will tear the moon apart, leaving rock and debris orbiting the planet. Over time, the rock and debris will create a ring system. The Asteroid Belt. Our next stop in the solar system isn't a planet, but a large, clumsy disarray of space rock and dust. The Asteroid Belt is an area of space between Mars and Jupiter that is filled with leftover material from the beginning of the solar system. Now, when you look at diagrams and models of the solar system, the asteroid belt is often portrayed as a dense disk of rock circling the sun, but this isn't true. The distance between two asteroids in the asteroid belt is very far. To be exact, the average distance of two asteroids in the belt is estimated to be around 966,000 kilometers apart. Next up, we land on another planetary body, this time Jupiter. Jupiter is the fifth planet from the Sun and the first of the gas giants. It's also the largest planet in the solar system. You might know Jupiter for its famous red spot, storm bands, and moons, but what you might not know is that Jupiter played a very important role in solidifying a sun-centered solar system model almost 400 years ago. Galileo, one of history's most famous scientists, used Jupiter as part of undeniable evidence that Earth was not the center of the universe, let alone the solar system. Part of his evidence was observations of Jupiter and its four brightest moons, Io, Callisto, Ganymede, and Europa. Using his handcrafted telescope, Galileo observed the position of these moons and noticed that over time they were orbiting around Jupiter, not Earth. This proved that other bodies in the solar system can orbit other objects besides Earth. Galileo used these observations of Jupiter and its moons alongside his observations of Venus going through phases like the moon does to prove that the sun was the center of the solar system. Jupiter has over 80 moons and a very, very thin ring system. Jupiter is also the second brightest planetary body in our night sky. You might be thinking, Mars is closer to Earth, so wouldn't it be brighter? Well, because of how big Jupiter is, it has a lot more surface area to reflect light. Thus, Jupiter appears brighter in the night sky than Mars. Saturn. Everybody knows Saturn. Saturn is the sixth planet from the Sun, the second gas giant, and the next stop on our tour. Saturn is known for its famous and stunning ring system. However, there are many other interesting facts about the planet. Saturn is the second largest planet in the solar system and home to over 50 moons. One of these moons, Titan, has been the center point of scientific research over the past few decades due to the possibility of it sustaining life. Research from the Cassini and Huygens space probes have found strong evidence of a liquid water with salt and ammonia ocean sitting under the surface of Titan. While we don't have proof of life existing on the moon so far, the chemical complexity of its atmosphere, surface, and underground ocean means that the moon has the possibility of supporting some form of life. Now, back to the thing that makes Saturn the famous planet, its ring system. Now, while Saturn is not the only planet in the solar system to have a ring system, it certainly has the most complex one. Saturn's ring system is made up of rock, ice, and the remains of moons destroyed by the planet's gravity. Although the rings stretch over 282,000 kilometers away from the planet, Saturn's rings are only about a kilometer thick. Because the rings are so thin in terms of thickness, this sometimes creates a very interesting event from here on Earth. Saturn's axis is tilted, and over time we can observe this tilt from Earth, but it's easier to observe because of the rings. As Saturn orbits the Sun, there are times when Saturn's tilt allows for the rings to line up directly with Earth. We call this the Saturn ring plane crossing, a cycle which happens about every 15 years. What this means is that Earth is on the same plane as Saturn's rings, meaning that from Earth we see an edge-on view of the ring system. Because the rings are so thin, it will appear from Earth that Saturn's rings have disappeared. Saturn's rings are very big and are broken up into 7 divisions, labeled A through G. While today here on Earth we enjoy Saturn's rings and all they have to offer, the materials that make up the ring system are slowly being pulled into Saturn, and it's estimated that in 300 million years, Saturn will cease to have a ring system. As we keep pushing farther out into space, we reach the next gas giant, Uranus. Uranus is the 7th planet from the Sun and is also the first planet in our solar system to be discovered. Back in ancient times, there are only 5 known planets to the visible eye: Mercury, Venus, Mars, Jupiter, and Saturn. Now, Uranus is just barely visible to a trained eye in clear and dark skies. Because of how faint the planet was, it was never noticed by ancient civilizations, and it wasn't until 1781 when astronomer William Herschel discovered an object slowly moving relative to background stars in a constellation. Not too long after, Herschel learned that he had discovered another planet in our solar system. Uranus itself appears pale blue. It has close to 30 moons and has a fairly complex ring system, though not as complex as Saturn's. Another thing Uranus is known for is how it rotates. Uranus actually rotates on its side. Scientists believe this happened due to a collision that happened sometime in the planet's past, forever changing how the planet rotates on its axis. This change in its axis also creates the most extreme seasons of any planet in the solar system. For a quarter of the planet's orbit around the sun, one of the poles faces the sun head-on, and this only changes as the planet moves around its orbit. This means that the side that is not facing the sun is put into a 21-year-long winter without sunlight. And now we reach the 8th and final planet in our solar system, Neptune. Neptune is the final planet in today's solar system, and I say that because Pluto used to be our last planet, but I'll get to that in a few minutes. Neptune is the last of the gas giants and is home to the fastest wind speeds in the solar system, with average wind speeds clocking in at over 1,100 kilometers an hour. To put that into perspective, the 1999 Bridge Creek tornado holds the record for one of the fastest wind speeds recorded on Earth, with ground-based Doppler radars measuring wind speeds a bit under 500 kilometers an hour. That is still less than half of the average wind speed on Neptune. Neptune was the second planet in the solar system to be discovered. However, unlike Uranus, Neptune's discovery was a team effort. Astronomers in the 1800s began to notice slight deviations with the orbit of Uranus, and scientists predicted this was due to another planetary body orbiting farther out in the solar system. So, on September 23rd and 24th, 1846, using the calculations from Urbain Le Verrier and John Couch Adams to predict the location of this mysterious planet, and with the observations from Johann Gottfried Galle, Neptune was discovered and labeled the 8th planet of the solar system. Neptune has just over a dozen moons and a very faint ring system. The planet is also home to temperatures well below 200 degrees Celsius. A fun fact, the planet has only been visited once by a spacecraft, Voyager 2 in 1989. We have not sent another probe there since. If we push past Neptune, we reach a few different categories of objects beyond Neptune's orbit. The first thing we reach is another space rock and dust-filled region of space called the Kuiper Belt. The Kuiper Belt is much like the Asteroid Belt, except it is much larger and filled with much more rock and ice left over from the creation of the solar system. There is also another category of objects beyond Neptune besides the Kuiper Belt, and these objects are called TNO. This includes what used to be the 9th planet from the Sun, Pluto, which since 2003 has now been labeled as a dwarf planet. A dwarf planet is an object in space much smaller than our 8 main planets, but has enough gravity to pull itself into a round body. This is why even though Pluto's elliptical orbit brings it sometimes closer to the Sun than Neptune, it is still very small compared to the other 8 planets in the solar system. Besides Pluto, examples of other dwarf planets include Ceres, which is located in the Asteroid Belt. But dwarf planets beyond the orbit of Neptune include Makemake, Eris, and my favorite, Sunda, which orbits so far from the Sun that at its farthest point in its orbit, if you are on the planet's surface, you can block out the Sun with the head of a pin. We finally reach our last destination in the solar system, the Oort cloud. The Oort cloud is a spherical area of space in the outermost region of the solar system and can be thought of as a case that encloses the solar system inside. It is made up of trillions of pieces of ice and space rock that can reach the size of mountains. The Oort cloud is also home and the starting place of some deep space comets that reach the inner portions of the solar system. Now, a comet is a piece of space rock or ice that in most cases orbits the Sun in extremely large elliptical orbits. These orbits bring these frozen ice and rock bodies from the outer portions of the solar system very close to the Sun. As these bodies get closer to the Sun, they heat up, and as the gas on the comet vaporizes, It releases dust and microparticles, which can be observed from Earth as a tail. The solar system does not have a defined end or edge. The Oort cloud can be seen as the final part of the solar system that the sun has gravitational influence on. However, if you judge the edge of the solar system by the part of space where the sun's magnetic field ends, the heliosphere would be considered the edge of the solar system. And with that, we've completed our trip through the solar system. The solar system truly is fascinating. It's home to worlds completely opposite of ours. It's home to unimaginable extremes. It's home to planets that we might one day step foot on, but most importantly, it's our home. The solar system is a great starting place for somebody who's interested in taking astronomy up as a hobby. There's so much different worlds to explore just within this small region of space. So that's it from me. Thanks for watching. If you want to see new astronomy and astrophysics videos coming soon, make sure to subscribe. Until then, take care.